we've seen what would happen when we draw Lewis structures. We've seen we can have resonance. We've seen we can have isomers. We've seen we can have bonded, and we can have lone pairs. So let's take a look at formal charge. Formal charge is the charge in an atom would have in a Lewis structure if all the bonded electrons were equally shared among bonded atoms. So that's a really confusing definition, but we're going to talk through it. So here's the equation for formal charge. We have the number of valence electrons minus the number of covalent bonds minus the number of electrons in lone pairs. So if we take a look at carbon dioxide, the first thing we need to do is draw the Lewis structure. So carbon has 4 and each oxygen has 6. So that is 16 electrons. Here's the structure. And now we can start looking at formal charge. So for the carbon, we take the 4 valence electrons minus the number of covalent bonds, which is 4, minus the number of electrons in lone pairs, which is 0. So the formal charge on carbon is 0. And we just put it right above the atom. If we take a look at oxygen, these two oxygens are identical. That makes life easy for us. And we can say that oxygen has 6 valence electrons minus 2 covalent bonds minus 4 electrons. So here are my 2 covalent bonds and my 4 electrons. So I do the subtraction and it's 0. And zeros, it turns out, are good. So you try the pH3 and the NH4. Start with drawing the Lewis diagram and then calculate formal charge for phosphorus and hydrogen. So pause, and when you're ready to see the answers, start it again. So take a look at pH3 and at NH4. We can see that for phosphorus, 5 minus 3 bonds minus 2 electrons gives us a 0. And for hydrogen, 1 valence electron minus 1 bond is 0. Hydrogens are always going to have 0. Let's take a look at NH4+. Nitrogen now has a +1 formal charge. So let's talk a little bit about what some of these things mean. First of all, if we have a neutral molecule, the total will always end up being 0. So we have 0 plus 0, 0 plus 0 plus 0 plus 0. If we have a charged ion, the total will equal the charge of the ion. So we have a bunch of zeros and a +1. The next thing to know is we want as many zeros as possible. The total's not going to change. So pH3 will end up being 0 no matter how the formal charge works. We want as many zeros as possible. The other thing we want is that we want a negative formal charge on the most electronegative atom. So if we have to have a negative somewhere, we want it to be on the negative the highly electronegative atom. If we have a positive somewhere, we want it to be on the least electronegative atom. So let's take a look at thiocyanate ion. Thiocyanate ion is SCN minus, so we end up with 6 plus 4 plus 5 plus 1, 16 electrons. So now I have a drawing that has all of the structural formulas with their lone pairs. So let's figure out how to do formal charge for each of them. I'll do the first one and then I'll let you do the later ones. So let's start with sulfur. Sulfur has 6 valence electrons, minus 1 bond, minus 6 lone pair, or lone electrons, sorry. And so that turns out to be a -1. Then we'll move to carbon, 4 minus 4 bonds. Then we'll take a look at nitrogen, 5 minus 3 bonds minus 2 unbonded electrons is also 0. So pause the video and find the formal charge for S, C, and N for the other two possibilities. Okay, take a second and make sure that your answers match mine. I have 0 on sulfur, 0 on carbon, and -1 on nitrogen, or +1 on sulfur, 0 on carbon, and -2 on nitrogen. So here's how it works. First, I want as many zeros as possible. So we can cross off this bottom one because the others have 2 zeros. Second, we want the negative charge to be on the most electronegative atom. So we know that nitrogen is more electronegative than sulfur, so we can cross off the top one. So the actual best structure is this one. So now let's take a look at 2 different versions of hypochlorous acid. Hypochlorous acid is typically written as HClO, but you'll also see it written as HOCl. Let's take a look at the two. So first, pause the video and draw the Lewis dot structures. Now our question is, are we better off with the chlorine in the center or the oxygen in the center? And we're going to use formal charge to figure it out. So the first thing I'm going to look at is hydrogen. Hydrogen is always going to have a 0 because it's always going to be 1 electron minus 1 bond. So that doesn't help us. Then I'm going to take a look at the chlorine on each one. On the left, I have 7 electrons minus 2 bonds minus 4 is +1. And on the right, I have 7 electrons minus 1 bond minus 6 unbonded is 0. And then if we take a look at oxygen, I have 6 valence electrons minus 1 bond minus 6 electrons is a -1 on the left. And for HOCl, it's 6 minus 2 bonds minus 4 electrons is 0. So we can see that HOCl is a better structure for our hypochlorous acid than HClO. And experimentally, this is the one that is correct. We write HClO because it's analogous to HClO2 and HClO3 and HClO4, but it's actually bonded as HOCl. So you may see it both ways. So that's just a brief introduction to formal charge. Formal charge is used to determine among multiple structures which is the best one. And we'll try more practice of this. If you have questions, let me know.